Solving a system of linear equations means that you're trying to find that exact point where two lines intersect. Of course, you may not always find a point because the lines may be parallel. And also, the solution might mean an infinite number of points because the lines could be exactly the same and fall on top of each other. Let's have a look at some examples. Before trying to solve a system, always think about what the lines might look like. We know these two equations are linear equations. Using Desmos, here we see that x equals 6 is the vertical line, which intersects with the blue line at 6, 0. 6, 0 is the solution to this system of equations. We can also solve this system using algebra by simply plugging in the value for x into the second equation. And it looks like this. 2 bracket 6 plus 3y is equal to 12. 12 plus 3y is equal to 12. We want 3y by itself. We'll subtract 12 both sides. 3y is equal to 0. Get y by itself by dividing by 3. What we do to one side, we do to the other. Y is equal to 0 divided by 3, which is 0. The value for y is 0, and the value for x was 6. Together, that makes a point. 6, 0. 6, 0 is the solution to this system of linear equations. First equation, second equation, these two lines intersect at 6, 0. We probably should check our answer. 2 bracket 6 plus 3 bracket 0. Does that equal 12? Does 12 plus 0 equal 12? And yes, 12 does equal 12. There you have it. We have a couple methods to solve systems of linear equations. We can use technology, such as Desmos, or we can solve by using algebra. Next example, we have two linear equations. The first one is a horizontal line because we have y is equal to 7. And the second one will for sure hit that horizontal line. Let's have a look in Desmos. Y is equal to 7 is that horizontal line. And 2x plus 3y equals 12 definitely hits. And the point that it hits is negative 4.5, 7. Using algebra, again, we're going to substitute y is equal to 7 into the second equation. 2x plus 3 bracket 7 is equal to 12. The 7 gets plugged in right here where we see a y. And we'll solve for x. 2x plus 21 is equal to 12. We want x by itself this time. We'll subtract 21. And definitely use your calculator so you don't make small mistakes. 12 subtract 21 is negative 9. Here's our 0 pair, and we have 2x on the left. Solving for x now, we'll divide by 2. What we do to one side of an equation, we do to the other. Therefore, x is equal to negative 9 over 2. The value for x is negative 9 halves, and the value for y is 7. When we're using algebra to solve, leave your answers in reduced improper fraction form. Let's check our work here. The x value and the y value will get plugged into the second equation. 2 bracket negative 9 halves plus 3 bracket 7. Does that equal 12? We have 2 times a half, or 2 divided by 2 is 1. And that leaves us the negative 9 plus 21. Does that equal 12? And I don't have a negative button on this calculator, but I can switch the order of adding. 21 minus 9, and that should give me the value that I'm looking for, which is 12. This equation is true. I know my solution to the system of linear equations here is negative 9/2, 7, which was exactly what we got in Desmos. 9 divided by 2 is that 4.5. In Desmos, we got negative 4.5, 7. I just realized something. This calculator does have a plus minus button. We could go 9 and make it negative and then add 21. There you go. Learn something new every day. We're getting a little more complicated. X plus y equals 3 is definitely a line, and x minus y equals 5 is definitely a line, and they probably hit. The first equation we'll call equation 1. The second equation we'll call equation 2. Let's graph these two. We have x plus y is equal to 3, and x minus y is equal to 5. These two definitely hit at 4, negative 1. Now, how would we go about solving if we didn't have graphing technology or graph paper? I bet you can maybe come up with a method to solve using algebra. What could we do? Well, what if we take this first equation and change the look of it? Why don't we solve for y here? Get y by itself. If you subtract x both sides, we would have y is equal to negative x plus 3. What would happen if we took this y and we plugged it in to the second equation? Isn't that what we just did in the first two examples? Sort of? Let's see what happens. We'll take that second equation, x minus y is equal to 5. We'll use negative x plus 3 in this spot. We'll have x minus x plus 3 is equal to 5. We have a negative 1 on the outside of this bracket. X, negative 1 on the outside of this bracket is equal to 5. We should distribute the negative 1 first in order to solve for the x. X plus x, negative 1 times negative x is plus x, and negative 1 times positive 3 is negative 3 is equal to 5. Now we can add up the x's to give us 2x minus 3 is equal to 5. We need a 0 pair. Add 3 both sides to make a 0 pair. And we have 2x on the left, 8 on the right. Now we divide by 2. 2 divided by 2 is 1, and we have x is equal to 4. The x value is 4, but what's the y value? Let's grab the first equation, x plus y is equal to 3. Plug in the x and solve for y. Subtract 4, both sides. Y is equal to negative 1. We have the solution 4, negative 1. But we should check. We'll use the first equation and plug in the values for the x and y. 4 plus a negative 1, does that equal 3? 4 minus 1, does that equal 3? And yes, 3 equals 3. We know 4, negative 1 is the solution to this system of linear equations. Good job.